All right, is my screen visible to you all?
Yes.
Okay, perfect. Thank you, Takwa. Okay, guys, so let's get started. As a lot of you may remember, last tutorial I left a particular question on tries that I told you we would discuss in the next session. Since this one is online, we're inshallah going to go over that question next week. So the agenda for today's tutorial is, well, we're going to be going over, I would rather say, some basic graph questions, and it would be wonderful if I can understand where you all stand with these concepts too. And then next week, inshallah, tentatively on Wednesday or on Thursday, we will have another in person tutorial, and I will try to include some harder difficulty level questions as well as some complex algorithm based questions. All right, with that, let's get started. I actually have a bunch of problems from lead code today, so you're going to find this interesting. Let's look at the first question. You are going to be given an undirected graph such that the graph forms the shape of a star, and your job is to find the center node of this star. All right, so there is an undirected star graph, star consisting of n nodes that are labeled from 1 till n. A star graph is a graph where there is one center node and exactly n minus 1 edges, so there will only be n minus 1 edges that connect the center node with every other node. So you are given this in the form of a 2D integer array of edges where basically u till v indicates an edge from u till v. Since it's undirected, it pretty much implies that v se u tak bhi the same edge would exist. All right, so you are required to return the center of the given graph. I'm actually going to give you all at least a few seconds to process this. It's one of those relatively simpler questions. In the meantime, I have a question for you all. How do you define the in degree of a node and how do you define its out degree? Yes, Nafe.
The in degree of a node would be the edges that are coming to that node, and the out degree would be the edges outgoing from that node.
Perfect. Thank you. Asad, I just saw your response as well. Guys, I would encourage you कि आप बेशक mic on करके बताएं मुझे in between, all right? Technically takes longer to just write the entire thing down too. Anyway, for an indirected graph, can I say that that the in degree of a node is equal to the out degree of that node? Can someone tell me why that is always true?
Because as you're going from any edge to another edge, since it's an undirected graph, it doesn't really have a direction going from one edge to another, so you can take it both ways.
या प्रिसाइसली सो टेक्निकली एक एज जो है वो अगर उस नोड के अंदर आ रही है तो वही एज उस नोड से बाहर भी जा रही है बिकॉज देन द एज डजंट हैव a particular direction. With that, so this particular question is concerned with, well, बस आपने डिग्री देखनी है हर नोड की. So can someone tell me how we're going to answer this? I don't need a piece of code right now. I just need the core logic of an algorithm. एंड आई वुड लाइक टू ऐड ओवर हियर कि रिस्ट्रिक्शन ये है कि आपको जो ग्राफ मिल रहा है इनपुट में दैट विल ऑलवेज रिप्रेजेंट ए स्टार, सो यू डोंट हैव टू चेक इफ इट रिप्रेजेंट्स अ स्टार और नॉट. ओके, कम ऑन पीपल, आई एक्सपेक्ट समवन टू टेल मी हाउ टू डू दिस. ये लीड कोड का इजी लेवल क्वेश्चन है ग्राफ्स पे. यस नाफे, गो अहेड.
You would just check how many elements each row of that 2D array has, and the one with the highest number of elements should be our center.
एंड जिसके हाईएस्ट नंबर ऑफ एलिमेंट्स हैं उसके कितने एलिमेंट्स होंगे एग्जैक्टली फॉर दैट मैटर?
For this graph, it should have three elements.
For this graph 3, but can we generalize that to any graph of size n?
Yes, since it's a star graph, it will be going through each node, so it's gonna be and the number of nodes minus one.
The number of nodes minus one, precisely. Now, who is going to help me write this algorithm down? A basic partial pseudocode लिखवा दें, but I need someone, some brave person here to give me an input for this. All right, this is the format in which you're given your function. You are given a vector of vectors such that जो उसके अंदर vector है उसका exactly ये format है. All right, so who can help me write down this code? It's just a few small lines of code, by the way. Come on, people, anything? Yeshil, could you please turn your mic on and go ahead with this? Acha, can someone add to the solution that Nafe proposed? It was fairly alright, but slightly vague. Can anyone other than Nafe add to this? बस आज ये मैं नहीं बताऊंगी आप लोगों को. Guys, can you all hear me? Am I still audible? Tahir, can you verify that? I'm double checking because my document just got stuck. Guys, am I audible? Can someone hear me?
Yes, Fiza, you're audible.
Oh, okay, all right. Acha, maybe I wasn't in between. Anyway, in case I missed someone over here, can someone tell me the solution for this? Yes, Amara, can't we just check two nodes in edges and vectors and see common node between them? Amara, can you elaborate on that? Please turn your mic on and elaborate on that.
Because there each of the nodes have are like connected to one center node. So if there are two nodes and have one common node, then wouldn't that be the center node?
Yeah, that's correct. You're right, technically. How can we do that algorithmically? इसको हम implement कैसे कर सकते हैं? So guys, there is a simpler solution जो आपके colleague ने propose किया and then उसके ऊपर further comment नहीं किया किसी ने. Technically, you just need to check the degree of each node. So Mahasan says edges 0, 0 equals edges. ये तो hard coded solution है Mahasan. This is a hard coded solution, right? This only works for one given node. Sorry, a graph with only two nodes, doesn't it? We can do it for I. Yes, Takwa, go ahead.
Over here, wouldn't we just, I could be wrong, but wouldn't we just store the UI and then check it for every VI that we have in the graph? In the, sorry, in the array that we have.
And what would the complexity of this solution be?
That would be n square.
That would be n square. Interesting. तो I'm gonna tell you guys कि इसको तो आप कर सकते हैं linear time में भी. So Sarish says, can we take the approach that the node with three edges here or has degree same as the number of edges will be the center? Precisely, we can do that as well. It's a very simple solution. But Filhal, let's check the degrees of all the nodes to begin with, and then eventually, if you're given certain constraints, like I mentioned, तो apply आप ये भी कर सकते हैं. So guys, in a single loop, can I calculate the degrees of each node? I'm going to specify over here again कि in degree is equal to out degree. So degree एक ही है. Can someone tell me the degree of node 1 in this given example? 1, precisely. What about the degree of node 2? 3, excellent. So I want a loop. जिस loop के result से मेरे पास ये degrees का जो vector है ये populate हो जाए. You are also given that the graph is always representing numbers from 1 till n. So just a vector of degrees जो n तक है, that should work. And suppose I've initialized this to zeros. Can someone help me write down the single loop which will help me populate this vector? Come on, people, even in pseudocode. Yes, Nafe, go ahead.
We can initialize the vector in degrees with size n. Then what we can do is we run a loop through the entirety of the edges vector, and whenever we check both the elements of each row, and we say that for the index that element minus one of the vector degrees
Yeah.
plus plus, we're sending incremental by one.
Precisely, precisely. Excellent. That's what I was looking for. So let's exactly write this thing down as well, guys. I'm sorry, my document for some reason keeps getting stuck. Okay, it's working. So for edge, आपको जो exactly given है वो edges हैं. So for edge in edges, अगर किसी को इस लूप से मसला है तो इसको एक्चुअली हम ऐसे भी कर सकते हैं. int I equals 0, I is less than edges dot size, and I plus plus. For simplicity, why not? Let's not complicate things. But later I am probably going to want to use this loop again. ये मैंने आप लोगों की assignments देख के सीखा था. So anyway, you can say that, okay, you want to check from u till v. So you can say that u equals edges I, and edges I में एक का size क्या है? Exactly 2, right? For instance, right now, let's highlight this. This is edges I. इसका size 2 है. So एक U node है इसके अंदर, and then there is a node that is V. So this can be the first node, this can be the 0th node. And I have to do this for both the nodes. So I'm going to do degrees u, and like you said कि आप इसको u minus 1 करेंगे actually, plus plus, and then of course degrees v minus 1 plus plus. Can someone quickly tell me कि मुझे u and v दोनों के लिए क्यों करना पड़ा?
Because it's an undirected graph.
Because it's an undirected graph, but like still, could you elaborate on that? Undirected graph, maybe why did I have to increment for both degrees? See, the thing is कि जो मैंने आपको representation दी, उसमें if I would have given you 1 comma 2 and then 2 comma 1 as well, that would have been fine. But I've only given you the set of edges, so इसमें आपके पास exactly एक edge जो है वो once ही आई है. As opposed to that, if I gave this to you in an adjacency matrix format, so then your algorithm would have been perfectly fine anyway. All right, can someone tell me what to do next? By the way, इसको अगर आपने initialize करना हो तो I think you can just, okay, let's see. I think that you can do it this way as well. Can someone verify this for me? Anyway, I'm sure that it's right. So now what I've done is कि मैंने size की degrees declare कर ली है and I've initialized each value to 0. All right, now I've calculated the degrees. My remaining solution is pretty much simple enough. Can someone tell me what to do next? I need another pass. Better to initialize to n? Yeah, Nafi, I was just about to do that. Then I realized कि n को मैंने कहीं पे declare नहीं किया. So instead I just wrote this. But yeah, I could have like taken a variable n and separately stored in it edges.size and then that would have been fine too. Anyway, moving on. Can someone tell me what I'm supposed to do in my next pass? Make another loop to find the node with degree not equal to 1. Precisely. So there are two ways of going about this. Now I'm actually going to implement dusra wala for loop as well. And let's see, for count in degrees. No, actually that's not going to work in this case. So for int I equals 0, I is less than edges dot size I plus plus, and then I can just see. So my condition could just as well be if degrees I is not equal to 1. Alternatively, I could just say if degrees I is equal to, and exactly like we determined, it should be n minus 1. So if this is true, then you will return I, or rather you would return I plus 1 since हमने 0 से count लिया है, but in actual it's not from 0 till n minus 1, it's from 1 till n. So anyway, are there any questions so far or are we good to move on? Yeah, I actually can't see the question. So Tahir, either you can help me out over here or whoever it was, आप please mic on कर लें.
I have a question.
Yeah, go on.
इसको instead of using a degrees vector to store all the degrees, can we use a map?
How would that help you out? Like, how would that simplify your solution?
I just like using maps.
I see. Okay, yeah, sure. You could use a map. For simplicity, I just used a vector. लेकिन आप बिल्कुल map भी use कर सकते हैं. आप कोई भी डेटा स्ट्रक्चर यूज कर लें as long as वो आपकी टाइम complexity नहीं खराब कर रहा. So can someone tell me the time complexity of this algorithm in terms of V and E? So आपको जब एग्जाम में भी अगर सवाल आए where you are concerned with the time complexity of a graph, so it's not in terms of n, because then what exactly is n? It's always in terms of v या e. जिसमें v को आप n कह भी सकते हैं. V is the number of vertices and then e is the number of edges. So in terms of v and e, can someone tell me the time complexity of this algorithm? O of e. Perfect. And I would like to add over here कि इस algorithm की time complexity को हम O of e भी कह सकते हैं. So we can do that as well because in this case, the number of edges is always equal to the number of nodes minus 1. All right, are there any further questions or shall we move on? All right, perfect. Let's move on. So let's look at question number 2. Actually, I have one small question for you guys over here. Let's quickly at least discuss this. Now, on the other hand, if I tell you कि मैंने आपको एक graph दिया है and उसमें you have exactly इसी तरह you have a certain number of nodes, suppose v, and then the number of edges are always v minus 1, and it does form a star, and now I give you a node and I ask you to check if the given node is the center or not. So how exactly would you modify your solution to do that? So Mahasan has a question. Would it still be a graph if 1 and 4 are also connected by an edge? Nay, in that case, it will not be a graph anymore. So if I give you a node and I ask you to check if this is if this is the center of the star or not, so how exactly are we going to do that? Guys, anyone? No, someone other than Nafe this time. Mahasan, please turn your mic on and elaborate on your condition.
So basically we've calculated the degrees here. So अगर वो एक सेंटर नोड है तो उसी इंडेक्स पे जाके we can check अगर उसकी डिग्री is equal to n-1 or not.
Precisely. So बस इस loop की जगह पे you will have a simple condition. All right, on that note, moving on. All right, let's look at question number 2. This,
Excuse me.
yeah, go ahead.
I had a question. जैसे वो अभी आपने बताया था अगर 1 and 4 connected नहीं है तो it wouldn't be a star graph. तो बेसिकली फिर जो एज सेट आपके पास जो एज का सेट होगा उसके अंदर बेसिकली सिर्फ सेंटर के साथ नोड्स कनेक्टेड होंगे, तो हम सिर्फ ये नहीं चेक कर सकते कि सबसे कॉमन एलिमेंट कौन सा आ रहा है उसके अंदर, सिर्फ दो सेट्स पकड़ के उनमें चेक कर लेंगे सबसे कॉमन कौन सा है.
दो सेट्स पकड़ के I don't exactly understand you. थोड़ा सा आप इस पे elaborate करें. Give me an example.
जैसे ऊपर जो एज सेट था उसके अंदर पहली टर्म थी 1 2 और दूसरी थी 2 3. सो वी कैन बेसिकली दोनों पकड़ के उनमें से चेक कर लें कि दोनों में कोई कॉमन वैल्यू है, अगर है तो वी कैन कैंट वी से कि दिस इज द सेंटर.
Interesting. Yeah, you can do that. Interestingly, I didn't think of that. तो इसकी time complexity तो आपकी actually constant हो जाएगी in this case. All right, wonderful.
ये
Okay.
रहता है.
Okay, you're absolutely right. So let's move on to question number 2. Again, you are given an undirected graph. अब आपको exactly उसी format में graph given है. You are given a set of edges only. And you're also given कि vertices आपके वही 0 से n-1 तक हैं. Actually, in the previous case, it was from 1 till n. Now they're from 0 till n-1. And you're also given a source and a destination. A fairly common problem. I'm pretty sure it was discussed in class to some extent as well. So now you have to check if it is possible to reach the destination from the source. All right. If there is a valid path that exists between the source and the destination, in that case you will return true. If no path exists between the source and the destination, then you will return false. I will give you all 60 seconds to read this question and think of a way of implementing this. Then let's discuss. By the way, guys, this is also a lead code problem. All right, let's discuss. So you have two graph traversals आपके पास BFS है and you have DFS. You're going to use one of the two to solve your problem. Actually, technically, you can use both. In this case, we are going to use one of them, which is more efficient for this problem. DFS. Thank you, Sarish. You're absolutely right. So आप DFS use करेंगे. Can someone just quickly turn on their mics and tell me how DFS works? Oh no, Nafe. In this class, we're not going to use the Dijkstra's algorithm or the Prim's algorithm. अभी हम बहुत simple काम कर रहे हैं, in fact. So we're going to implement DFS. Can someone tell me how depth first search works? So I'm going to show you guys one interesting way of interpreting these. अच्छा, अभी हम directed graph नहीं बना रहे, my bad. We're making an undirected graph. But then we're definitely going to try and solve this problem for a directed graph as well. All right, one thing that really helps, in my opinion, is making a traversal tree. So let's suppose that my starting node is, of course, you're given a source, let's call it S, and you're given a destination. So in this example, let's suppose कि आपको जो source दी हुई है, that is 0 and the destination is 4. So you have to check if you can get from 0 till 4, and on based on this path, we can do that as well. Quickly, I'm going to make a tree of this and let's see how this works. Wouldn't disjoint set union also work on this? Yeah, it would, but we're going to do something even simpler. Okay, for simplicity, okay, you're gonna start with 0. 0 के नीचे आप वो सारे nodes बना लें which are the immediate descendants of 0. All right, so I have 1 and I have 3. And then I do the same for 1. From 1, you can reach 2 immediately. From 3, you can reach 2 or 0. जब आपके पास repetition आ जाए तो you can stop making this tree. All right? And then, of course, here you were standing at 2. From 2, you can reach 3, you can reach 1, and you can reach 4. So जहाँ पे आपके पास 1 आ गए, it means that your path stops right over there. 4 के आगे you can only go to 2, which is the immediate parent of 4. So you can stop this path as well. And then ahead of 3, of course, you could go to 0 and 1. So there is no need to do this, and this, as well as this. And then, of course, here underneath 2, it's actually pretty much the same path. So I'm just going to make 4 now. Since we know you can go from 2 till 3, 1, and 4. But like 3 is right over here. And oh, okay, actually, I can make 1 here. Okay, generally, it helps to make a tree like this. So essentially, if you were to apply breadth first search to this, तो exactly वो इस fashion में work करेगी. When it encounters this node, you're actually gonna stop. But we're not discussing that problem right now. So this is the fashion in which your breadth first search will work. Starting from 0, then it will explore 1, then 3, then 2, and then 2 is already explored, so it's already recorded. Then it will visit 3, 4, and well, 1 and 4 both have already been visited. Alternatively, अगर आप DFS implement करें, so this is how that will work. It will go to the depth of this node, and then once it has reached the depth, तो फिर ये ऊपर जाएगा to the last node जिसकी depth तक अभी तक हम नहीं गए, and then it will explore that. So then it will go to 3, 2, 1, and then eventually from 1 it backtracks to 2 and then moves on to 4. For this particular example, we know कि 0 से 4 को reach करना is possible. Let's see how you can do that using either of the two algorithms. अगर आप breadth first search use करें तो you will go to 0 1 3 2 2 3 4 and you will stop over here. So आपको कितने nodes visit करने पड़े before you were able to return? So let's see, 1 2 3 4 5 6 and 7. 7 highlighted nodes हैं जो हमने visit किए before we were able to reach 4. Now let's suppose you were implementing depth first search instead. So you will go over here. After that, you'll backtrack to 2. You'll go over here and you have found 4. So 1, 2, 3, 4, and 5, which is why for this problem, DFS seems a lot simpler. Although this may not always be the case. If you have a very large graph, for instance, तो it's possible कि आपके पास breadth first search में यहीं पे वो node आ जाए. For instance, if 0 and 4 were directly connected. Alternatively, depth first search would mean that you would have to go until the depth of a lot of branches before you're finally able to hit the node that you were looking for. So, how do we implement BFS and DFS in code? We're not going to implement both of them in code right now, but I just want to understand कि एक particular data structure है जो different होता है दोनों में. एक में आप stack use करते हैं and एक में you use a queue. Can someone tell me which corresponds to which algorithm?
The queue corresponds to BFS, and I think the stack corresponds to DFS.
Precisely, exactly. So let's suppose कि अब हमने DFS implement करना है. All right. So I'm going to write down a very small function for DFS. Yeah, let's just call this DFS ही actually. And suppose कि DFS को आप pass कर रहे हैं अपना graph. All right. So what am I going to do over here? I'm going to maintain a stack. All right, and usually what do we call this stack? इसको हम कहते हैं this you contain the nodes over here that you are opening that you're going to visit then. So you have a stack of integers that let's call it, well, let's just call it visited, okay? Can someone help me finish this? What do I do next? एक loop लगेगी. Can someone tell me what my loop should include? We're not concerned with the destination right now. I know I want to start at the source, but can someone tell me where I go to from there? I believe your PA is due in 2 days. There is no way that there is anyone in this crowd जो BFS या DFS का function ना लिख सके. So come on. Nafi, you're gonna have to elaborate on that. Please turn your mic on.
If say we have a helper function that gives us all the nodes that are directly connected to the node we are starting from,
Yeah.
we'll run a for loop and run BFS on all of those nodes.
Okay, so you're going to run a for loop. Suppose कि for every what? For every child of that given node, yeah, for every neighbor of that node, right?
Yeah, it would be the same thing in this case.
Precisely. So let's call it, I'm just gonna write it as x. For every x in graph, and I'm writing S for source or the start. I mean, because for instance, हमारा start 0 था, so I would want to start exploring the immediate neighbors of 0. Okay, and what do I write inside this code now?
We would call DFS for every x.
अच्छा, so ये तो आपका recursive algorithm है. There is no need for a stack anymore. Okay, and I agree with the recursive approach for this question actually. So you're going to call DFS and DFS on. Acha, so we're gonna have to modify this slightly over here. इसमें आपको node भी specify करना होगा, right? So suppose first of all you called it for the starting node. Yeah, actually let me just write S over here then. And then you call it for X, correct? The same graph, but you call it for X. So this is actually going to run infinitely. What is my base case over here? Ab I'm going to slightly modify your function and add one important thing to it.
Hmm.
अब हम
That is
destination भी
amazing.
add कर देते हैं. So now can someone tell me what your base case should be? वरना ये जो आपका कोड है, well actually ये infinitely नहीं चलेगा, but this will visit every single node and then well it won't return anything. The function will just end. But you're just visiting them and visit आप उन्हें exactly इसी order में कर रहे हैं, but you're not doing anything with them. If S equals D, excellent. Zehra says if we had to implement via stack, would we first pop the element in stack? Zehra, let's visit that as well. In fact, इसको भी एक दफा जल्दी से हम देख लेते हैं. But first, let's complete this particular code. So I'm going to add my base case over here. If source equals destination, actually इसको हमें source भी नहीं कहना चाहिए फिर because then that will be slightly confusing. Let's call it n. So अभी जिस current node के ऊपर अगर हैं आप, it's the current node n, then that means that you have been able to reach the destination from the source. मैं इसको n भी नहीं कहूंगी, अब ये n भी मुझे confuse कर रहा है. It's actually the current node that you are on. So in what case does it return false then? My code is still missing something very important. Can someone comment on this? बस अब इसमें एक चीज missing है. This is going to return true only or nothing. When does it return false and where do I add that piece of code?
At the very end.
Yeah, precisely. And Zara, you're also right. At the very end, हम एक line लिख देंगे that says return false. So इसका मतलब है false सिर्फ तब return होगा जब there is no path between those two nodes in a graph. I have a follow-up question over here. Can someone define a connected graph? A couple of terminologies which you've been over already. False should be at the end after the for loop. Yeah, okay. Oh, we've already been over this. So can someone tell me what is a connected graph? अभी directed या undirected की बात कर रहे हैं. What is a connected graph?
In a connected graph, there is a path between every pair of vertices.
Interesting. Yeah, that is actually correct. Can someone tell me the difference between a connected graph and a complete graph? अब ये दो slightly different terminologies हैं. So in a connected graph, all the nodes are connected via some edge. In a complete graph, you can reach any node from any other node. Like जो complete graph है उसमें आप किसी भी node से start करके किसी भी source से किसी भी destination पे पहुंच सकते हैं. In the case of an undirected graph, you can say that a complete graph is equivalent to a connected graph. Since directions नहीं है, तो अगर complete है graph, तो इसका अगर connected है graph, तो इसका मतलब है कि वो graph complete भी होगा by default. In a directed graph, on the other hand, it is possible to have a graph जो connected हो but complete ना हो on account of directions. So anyway, for this particular example, in case of an undirected graph, let's suppose, let's go ahead and I want you guys to now be able to check if a given undirected graph is connected or not. So how are we going to do that? I think we can expand on this solution. सो अभी जो हमने एल्गोरिथम लिखा है वो आपको ये चेक करके दे रहा है कि आप एक सोर्स से एक डेस्टिनेशन तक जा सकते हैं या नहीं जा सकते. Now I want you to check if you can go from any source to any destination. How can we do that?
We can check for the number of children. If the number of children is equal to n minus 1, then it's a connected graph.
Number of children of a particular node?
Yes. Of all the nodes, actually.
Of all the nodes. Achha, so it's like if you're standing at 0 to 0 ke to ye do children hai, 1 and 3. You're almost there though. Yes, Nafi?
We can use a nested for loop, and
Uh-huh.
we iterate between every starting node and every ending node, and we keep a bool, and if that bool is ever true or false forever, we will conclude that point was not reachable by a DFS, and therefore the graph is not connected.
Precisely, that's what we're going to do. So guys, now you're just going to have a nested for loop जिसमें आप हर दो nodes के against check कर लें. But then can someone tell me or rather can someone first tell me the time complexity of our algorithm जो हमने अभी लिखा है, where you're checking if you can go from a source to a destination? Just let's begin with this one. इसकी क्या time complexity है in terms of the number of nodes and the number of edges? O of V.
O
Can
of
someone
V plus.
verify that?
I think it's V plus E
It's V plus E. And how is it V plus E?
because V is the number of vertices and E is the number of edges, and the DFS visits each vertex and each edge at most once.
Precisely. So that is all right. So what about the other algorithm that we just discussed, Abhi, where you're checking if an entire graph is, well, complete or not, an undirected graph. फिर जो उसमें हमने approach discuss की है, उसकी क्या time complexity है? Alright, so guys, I'm going to add something interesting over here. आपको इसमें technically nested for loops की ज़रूरत ही नहीं है. Because in a nested for loop, what you would do is कि आप बाहर वाले loop में, for instance, you take a node 0 and then you check 0 against all nodes to see if it's reachable, to see if every node is reachable via 0. And then you do the same for 1, for 2, for 3, for 4, all the way up until n. Technically, if I do this just for 0, it should suffice. So I'm saying कि अगर आप कोई एक random node ले लें and then you just check if every single other node is accessible from that one, so that should also suffice. Can someone tell me why that's always going to be true? Yes, Nafi.
Is it because it's an undirected graph?
It's an undirected graph.
No, but
But that's not quite what I was looking for. This is always going to be true because एक नोड से अगर आप बाकी सारे नोड्स पे जा सकते हैं तो evidently it means that you can go in between those nodes as well. ऐसी
but
कोई एग्जाम्पल नहीं एग्जिस्ट करती जिसमें आप एक नोड से बाकी सारे नोड्स पे जा सकें but then there are certain nodes from which you can't reach other nodes at all
but
because essentially, yeah.
isn't this possible? Isn't the situation you're saying which is not possible? Isn't it possible for a directed graph?
Oh, yeah, yeah, absolutely. For a directed graph, it is. But abhi we're talking about undirected graphs. And we're checking the completeness of undirected graphs. जो
I
solution
had
आपने
a question.
बताया है वो डायरेक्टेड ग्राफ की कनेक्टेडनेस को चेक कर सकता है बट वो डायरेक्टेड ग्राफ की कंप्लीटनेस को नहीं चेक कर सकता. we're not going to check the completeness of a directed graph right now. Yes, go ahead.
अगर हमने चेक करना है कंप्लीटनेस तो हम सिर्फ एजेस काउंट करके ये नहीं चेक कर सकते कि एजेस n चूज 2 के इक्वल हैं, क्योंकि वो मैक्सिमम होते हैं कंप्लीट ग्राफ.
Let me just think about this real quick. You're saying कि in an undirected graph आप edges count कर लें which should be equal to n choose 2. Let's see. So suppose कि आपको यही graph exactly given है where n is equal to 5, right? And the edges are equal to 1, 2, 3, 4, and 5. So what is n choose 2, 5, C2 going to give you?
I think it's 10. Let me just check.
Sure, all right.
Yep, it's 10.
It's 10. So अभी जो हमारे सामने ग्राफ है वो तो complete है and connected है, but the number of edges are not equal to 10, right? So that means that this doesn't work. Okay, let's move on. Yes, Takwa, go ahead.
I'm a little confused about how it's a complete graph, the graph that we just saw.
Right, okay. अच्छा, so आपके पास जो, let's quickly dial back and understand the difference between connected and complete as well. So a connected graph is a particular graph जिसमें सारे आपके जो नोड्स हैं वो आपस में कनेक्टेड हैं. आप किसी एक नोड से किसी दूसरे नोड पे जा सकते हैं. For instance, let me give you another example. A, B, C, D, E. This is not a connected graph. बिकॉज इसमें आपके पास एक ये वाला पोर्शन एग्जिस्ट कर रहा है एंड एक ये वाला पोर्शन एग्जिस्ट कर रहा है. दिस इज अ कनेक्टेड ग्राफ बिकॉज इन दिस पर्टिकुलर ग्राफ अगर मैं किसी एक नोड से स्टार्ट हूँ तो मैं जीरो से किसी भी और नोड पे जा सकती हूँ. इफ आई वॉन्ट टू गो फ्रॉम 0 till 4 फॉर इंस्टेंस तो आई विल फॉलो दिस पाथ. इफ आई वॉन्ट टू गो फ्रॉम 0 till 3 आई कैन डू दिस. From 0 till 2, I can either do this or I can do this. And I can do the exact same thing for all the other nodes as well. Does that make sense?
Yes.
So आपका जो connected और complete graph है undirected के केस में वो दोनों same होते हैं because I can go from any node to every other node and that means that a graph is complete. But
Okay.
but directed graph के case में this may not always be true. Let me show you. For instance, suppose I have A, B. Oh, hold on. A, B, C, and D. So now I'm going to make a connected graph. Suppose I make an arrow from A till B, B till D, C till D, and then A till C as well. ये graph connected है. All right, because if I am here at A, so A say I can go to all three of these nodes as well. If just one of these exists, तो ये graph आपका connected है, but this graph is not complete because if I'm standing at C, तो C से मैं सिर्फ D पे जा सकती हूँ. I can't go to A and I can't go to B. So this is not a complete graph. अगर इसमें directions ना होते तो it would have been complete as well. So I hope that answers your question.
Yes, that makes sense. Thank you.
You're welcome. So Yashil says, can there be an edge 1, 1 in an undirected graph? I have never thought about that before, but I'm fairly confident that the answer is no. Still, let me look into that again and get back to you on this. I think generally ऐसा typically directed graphs में होता है. It doesn't happen in undirected graphs. Alright guys, on that note, let's move on. Oh, all right. I could have just shown you this as well. This is an example of a particular graph जो connected नहीं है and complete भी नहीं है. Obviously, since it's undirected, so this particular graph is neither connected nor complete. And interesting. So in this question, we actually have to check the connectedness of a graph. You have to check the connectedness of an undirected graph. In this case, you are given a set of edges again. So I will give everyone 60 seconds to read through this question once and think of a solution. Then let's discuss this. All right, guys, let's discuss this. So, सबसे पहले we are given edges. I don't think that you can solve this problem just using edges. Can we use a list of edges to create a graph in the form of बेशक आपके पास adjacency lists हैं या adjacency matrix है. So we can actually do either of those two things. Let's try and create an adjacency list. Very quickly, I'm going to show everyone what an adjacency list is as well. Technically, probably everyone should know, but anyway, very quickly, let's look through this. So, अगर मैं इस graph को adjacency list format में लिखूं तो this is what that would look like. 0 के आगे I would have 1 comma 3. Ahead of 1 I should only have, oh, I should have 0 comma 2. For 2 I have 1, 3 and 4. So you only have the immediate neighbors in this format. Against 3 I have 0 and 2. And of course against 4 I have only 2. I'm actually going to erase this part as well. So I'm asking you if we can use our set of edges to create something that looks like this. ये एक for loop में किया जा सकता है. Can someone help me implement this for loop? So essentially जो मैंने आपसे पूछा है इसकी type आपके पास होगी, well, you're obviously gonna have a vector of vectors basically. And let's call it our graph here, in fact. Can someone tell me how I can fill this out? You just need one loop. You just need one pass through the edges in order to create a graph. All right, people, someone's gonna have to tell me. ये तो simple traversal है. It's not even your DFS or your BFS. Essentially, we've been through something very similar in our first question. And I still have one more question left after this. Can someone please comment on this? Eventually I want to have a result that looks like this. I want के zeroth index के against I have 1 comma 2. I want के first index के against, well, I have only 0. And then against my second index I have only 0. Can you guys hear me? Yes, Nafi, can you hear me or are you like verifying that? Yeah, okay, all right, perfect. I am audible. I thought कोई issue होगा. Anyway, so against 3 you have 4 and 5 and well, I'm not gonna finish this. Anyway, how can I write one loop जिससे मेरे पास ये वाली list आ जाए? Okay, hold on, Nafi. I have a solution from Ariba. We can run a loop over edges, then int u equals edges 1, 0, int v equals edges 1, 1. Excellent. That's what I was looking for. Yashal dot first dot second. I don't think first second हमारे पास इस format में होते हैं available, but I may be wrong. So let's see. You're going to do for now I'm just gonna write for edge in edges. All right. So for edge in edges, int u equals edges, sorry, edge 0. So this is for exactly when I say edge 0. So again, I'm just talking about this particular thing. And then int v equals edge 1. And then I can just do this graph u dot push back use करते हैं आप लोग push back v and then graph v dot push back u. Is everyone clear on this? Are there any questions? Okay, so ये वाला format तो आ गया हमारे पास. I'm just going to come back over here. We were right over here. I didn't realize this was open in two windows. Anyway, once you have this, so now what are you gonna do with this? इसको use करके आप कैसे check कर सकते हैं if a graph is connected or not? I'm going to quickly remove this from here. All right, now you have an adjacency list format for your graph. How can you use this to determine if your graph is connected or not? People, we've already been over this solution. Come on.
We just call dot size on each and see if the sizes सबके बराबर नहीं है, then it's not connected.
Sizes सबके बराबर नहीं है. Oh, but that's not the case over here. इसका size 2 है, इसका 2 है, इसका 3 है, 2 है, and 1 है. But this graph is connected. I would want it to return true, right? So this solution fails. Yes, Nafe?
We could just run DFS like we did before. Start from one node and then we can just check if it can reach every other node with DFS.
You can start from one node and then you can just check if it will reach every other node.
Yeah.
So I'm just going to copy this exact piece of code and let's try and understand कि इसी को हम कैसे modify कर सकते हैं for our solution. It's very simple. अब ये वाली condition जो है we no longer need this because हम किसी source या किसी destination की बात नहीं कर रहे. So I'm going to remove this.